Franchising. Guys, our pizza has done so well. We're now franchising around the country, but different parts of the country want to do things slightly different. New York doesn't want to make pizza the way Chicago wants to make pizza, right? So we make our basic pizza store abstract. What we're going to do is we're going to make our basic pizza store abstract and pull the create pizza method back in, but make it an abstract also. So our franchisees have to create their own version of create pizza. That might sound confusing. I'm going to show you. It's not nearly as confusing as it sounds. Basically, we're abstracting the store now, and the factory is going to be the franchisees that implement the pizza store abstraction, and those franchisees will have to make their version of create pizza. We also make the pizza class an abstraction now, because it's really been an abstraction the whole time, right? You got to look at your classes sometimes and say, is this really a class? Pizza wasn't doing anything but just throwing sauce out on a crust. Yuck. So we abstracted the pizza so that our pizzas now have to, well, they've already been inheriting, but now they're going to implement the abstraction. All right, so let's look at the details. Okay, looks like I didn't finish my sentence. Our pizza store is an abstract class, okay? And which means it has to be implemented. Inside of the pizza store, we have a method called order pizza. Our implementers won't have this. This will happen inside of the order pizza class, or inside of the pizza store class, sorry. But it does call create pizza, which you can see below. This is an abstract class, meaning that anyone who implements this pizza store abstraction will have to create its own create pizza method, which allows the factory to decide what it's going to do. I think I just said all that, right? Bringing create pizza back in, but making it abstract, so other stores have to do their own version. Since this is abstract, the method doesn't know anything about the process, right? The pizza store doesn't care, doesn't know anything about what's going on inside of create pizza. It just knows that it's going to get a pizza back. That's the beauty of the factory method. The subclasses get to decide all the details, thus decoupling our main class from the decision making. All right, so a method, when we do this, well, let me go down and show you these subclasses first. So here, New York Style Pizza Store is going to implement Pizza Store, and the only thing it has to do is implement the create pizza. And so we pass it the string of the type of pizza that we want, and the New York Style Pizza Store gets to decide what kind of pizza is coming back. So this I doubled up on logic, doesn't matter. If it's a cheese pizza, it's going to send back a New York Style cheese pizza. If it's a pepperoni, it's going to send back a New York Style pepperoni pizza, and so on and so forth. And here we have a Chicago Style Pizza Store, which does the same thing. The subclasses are deciding what comes back based upon whatever arguments it gets or whatever your logic is. Also, as I said above, our pizzas are abstract now. So we've got, and we added, this is just some extra information for our own sake to look. But because it's abstract, now our pizzas are implementing the abstract, and they are deciding what goes into the pizza. So New York Style Greek pizza is now a pizza, but it's an abstraction. It's not an inheriting from a concrete method. All right, so what we're seeing here is we have a single method, the create pizza, that returns a single type of object. This is what's called the factory method pattern. The factory method pattern defines an interface. Now, when we say interface, we mean abstraction or an abstract or an interface. Interface as in a programming term, not the real programming interface. But it defines an interface for creating an object, like a pizza. But it lets the subclasses decide which class to instantiate. Factory method lets a class defer instantiation to its subclasses. All right. So let's order some pizzas. So you can see here, using this method, we're going to create pizza stores so we can order pizzas. And we decide which type of pizza stores we want to order. We want to create, I'm sorry. And then Marjorie is going to order she's going to order from the New York store, and she wants a New York style cheese pizza. Let's watch that go. So Pizza Store is going to call its own order pizza, right? Because that doesn't, she called New York Store order pizza, but it's an abstraction. So we're doing this. But now when we go to create store or create pizza, I'm sorry, it's going to jump into the New York style pizza store. And it's going to create cheese because I did that wrong. But it's going to send you back a cheese again. No biggie. We get the New York style cheese pizza because that's what Marjorie wanted. Now we're jumping down into the New York style cheese pizza. And it's going to set its name, do its dough, do its sauce, add its toppings. We're done getting the pizza, and our New York Pizza Store factory is going to return the pizza. We're going to prepare it, bake it, cut it, box it, return the pizza in our abstract class. And Marjorie gets her pizza. Let's see. Prepared the New York style pizza, thin crust, marinara, get some grated Reggiano cheese. Awesome. We did all of our other things, and Marjorie now has a New York style cheese pizza. Same thing for Sean, but he wants Chicago pepperoni. You can see we're in the Chicago style store. Boom, 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 boom. And there we go. Sean gets a Chicago style pepperoni pizza, extra thick crust, plum sauce. I almost said plume sauce, shredded mozzarella, Italian pepperonis. I didn't know what type of different pepperonis there were, so I just kind of made that up. And then here's our preparation. Sean's got his pizza. That's the factory method pattern. I keep trying to close that when I'm debugging. And let's just talk about some final thoughts. This is known as the factory method pattern. All factory patterns encapsulate object creation, products, aka pizzas, or any family of other products, like in our instance, audit logs, assessments, other things. The factory method pattern encapsulates object creation by letting subclasses decide what objects to create. The official definition, I've already read it, but I'll read it again. The factory method pattern defines an interface for creating an object. Interface not being a C# interface, but an interface, abstraction, that kind of thing. But it lets the subclasses decide which class to instantiate. Factory methods lets a class defer instantiation to subclasses. So we have product classes like our pizzas, audit logs, assessments. We have creator classes, which are the factories that create and hand us the very exact item, exact product that we want. This example used an abstract method and subclasses, or an abstract class, not method, well, and a method and a class to achieve our factory method pattern. But the parent creator class could have used its own concrete method to return a pizza, abstracted just one way to achieve our goals. The goal is to decouple. We can now add new factories, change how the factories make pizzas, make any number of changes, all without our concrete class and clients having to be changed or having to worry about anything. Our pizza store used to depend also, this is really important, everybody. Our pizza store used to depend on low-level objects, the pizzas themselves. So our pizza store is a high-level object. It's one of our top-level objects, and it's depending on the low-level objects, the concrete pizzas. When it said, give me a new cheese pizza. That's bad, because if it wanted a new Greek pizza, and then somewhere along the lines, we decided the Greek pizza needed a couple extra arguments. Now we have to go in and we have to change our pizza store. Just like that. So our high-level object was depending upon a low-level object. But with this, and also with the simple factory, we remove the high-level component from being dependent on the low-level component. It is now only dependent upon an abstraction, an abstract pizza, and an abstract interface, which is a method that is called by its subclasses. Also, the concrete pizzas before, they are now dependent upon an abstract pizza class as well. Before, they were dependent upon a concrete pizza class, which again, if that changed, now we have a problem. So in other words, all components are dependent upon an interface now, which in this case are all abstractions, just in this case, but any kind of an interface. So what we've done here is we've done the D in solid. Again, as we said, solid is our 5 principles, guiding principles for object-oriented design. D is the dependency inversion principle, which states high-level modules should not depend on low-level modules, but both should depend upon abstractions. So this is exactly what it's talking about. We now have our pizza store dependent upon abstraction. We have our pizzas dependent upon abstraction, and that has decoupled from concrete instantiations. It makes things way better.